Hello everyone, I'm Sachin. As I already introduced, I work for a company called Yodlee, which is into financial aggregation, and I look after the security of web and mobile application. So today I'll be talking about the various attacks that are possible on Android web views. So as I understand, not many of you are developers, so I'm assuming that you may not even know what is a web view, what is a web native bridge and a hybrid mobile application. So is my understanding correct? Okay, so this is the agenda. So I'll quickly cover like what is hybrid mobile application and what is a web view and web native bridge, which is necessary to understand the various attacks that I'll be demoing. Then I'll be showing some demos for by bypassing same origin policy as well as the sandbox, and there are a bunch of some interesting demos which are lined up, which will demonstrate the reflection based attacks. And finally, we will see how to go about securing this hybrid mobile applications from these attack vectors. All right. Okay, so what is a hybrid mobile application? So hybrid mobile application has two components. One is the web component, other one is the native component. So the native component is the one which is coded using C, C++, assembly, etc. And you write it using Android NDK or SDK. In case of you can also write it in Java. And this native component, it has the access to all the APIs in order to access the system resources, which means that you can this code can basically access the file system, it can access GPS, cameras, etc. However, on the web component is the one which basically requires the pages to be loaded from the remote server and rendered. So it's a web browser inside Android application. So as like any other web browser, it is having a sandbox restriction, which means that the pages which are loaded on the browser cannot directly access the file system or any of the system resources. However, in case of hybrid mobile application, from the design, they have given something called as a bridge. So this bridge enables the pages that are loaded in the web view or the web component, right, to access the system APIs which are exposed and hence access the system resources. So now the pages which are loaded on the web view from a remote server can now access the system resources like file system, write to a file, read from a file. So the basic design of this hybrid mobile application breaks the sandbox functionality, right? So let us see some code now. Yeah. Yeah, so this is the native part of the Android application, of the hybrid mobile application, where you create the WebView object. So here you create the WebView object here, which means that you get a web browser component within the mobile application, and then you basically call webview.add JavaScript interface. So this is the method which basically creates the bridge, right? And this is the class, this is the object of the class which you create here, which exposes the method over the bridge. For example, here you have write str2 file in the class, and this particular method is exposed over the bridge, and my bridge is the bridge handler. Clear? So again, let me tell it. So you have this write str2 file, which is a native API which is exposed over the bridge, and the bridge handler is my bridge. And finally, you load the HTML the page from the server. Now let us see the web component. We saw the native component, which is the Java code. Let us see the web component. So the native component, the web component, what you do is you use the bridge handler and directly call the API, right, which is exposed over the bridge. Which means that now if you call my bridge dot write str2 file, you will be able to write the page which is rendered from the server will be able to write contents into the file system, which is otherwise not possible because of the sandbox restriction put forward by the browser, right? So by design, it breaks the sandbox functionality. So let us see a demo now. Okay, so you see my device here. So let me open the first application. This is a normal application, normal blogging application, right? So nothing malicious about this. So you basically submit this application to the Android Play Store, and Google is fine with this. No, it's nothing malicious in nature. Just gives the displays the block. And now after the users download the application is being used, the developer himself can actually change the page, or the server in which the page is loaded. Basically, this is a hybrid application which loads the server loads a page from a remote server. Now the server can get compromised and the page can be changed. So now let me change the page, and then let me reload the application again. You see that the entire mobile application, the look and feel, everything has changed, and it looks malicious. It's not malicious because of the picture or the message that is there. It is malicious because if I click this button, click me if you hate anonymous, I see I see my mobile the phone numbers, the contact list on the device, as well as it is sent to a remote server. So which means that the contact list from the phone is sent to the remote server. Now let us see what is happening in the background. So this is the hybrid application which I opened. So if you see here, like I have the JavaScript, it's visible, right? I have the JavaScript object and the handle, and this basically exposes the method called contact list. Now just think about it, it's a blogging application. Why would a developer actually expose a method called get contact list in a blogging application? So for developing hybrid application, there are a lot of frameworks available like PhoneGap. So by default, these frameworks, they have all the APIs that exposes the system resources. Say like there may be around 40 to 50 APIs which expose all the system resources, and they expect the developer to whitelist what APIs need to be allowed to for the page to be for the page to access. However, most of the developers don't whitelist the APIs, and they just directly package their hybrid application without whitelisting, and hence this gives an attacker a chance to basically load a page and use any of the APIs that is exposed. Let us look at another attack scenario, which is the same origin policy bypass. Okay, you would have seen a hybrid mobile application where like you see ad which is displayed at the bottom, right? So how this works is like you usually like if it's hybrid mobile application, the page is loaded from the server, and the ad page is basically displayed within the iframe that will be connecting to a different domain, which means that it's a different domain. The ad is displayed in different domain compared to that of the main page, right? So the same origin policy applies here, which means that a page, that is the ad page, cannot access or modify attributes of the main page, and similarly the main page cannot modify the attributes of the ad page. So this is the same origin policy restriction of that is given by the browser. But because of the architecture of this hybrid mobile application, right? So we have a bridge that is exposed to the JavaScript code, right, which is being rendered from the browser. So not only can the main page access that bridge, but also the ad page also can access the bridge, which means that now if you expose any methods and if you give a bridge handler to the web layer, even the ad page can basically call those APIs, and it can actually indirectly modify the attributes of the main page. Let's see a demo now. Yeah, so let's see the device. So I have a ABC bank. So basically this bank, this application renders a page from a remote server and gets me the account balance, right? So I can refresh and I can get the latest account balance. And then there is an ad page which is loaded in a separate iframe which is connecting to a different domain, and there's a button there. So let us see what happens when I click refresh. I click refresh. Fine, nothing changes. Now let me click get rich within that iframe, which is pointing to a different domain. I have clicked on get rich, and now let me click on refresh once again. You see that like the account balance becomes 0, which means that when I click a button within the iframe, it modifies the property of the main page. So now let us see the code and understand what is happening here. So this is the native component. Again, we'll be seeing the native component and the web component. So this is a native component, pretty straight. You have the handler defined here, and this native component exposes method read account balance and write account balance. Basically, it writes the account balance to a file and reads it from a file. Okay, so these two methods are exposed over the bridge. Now let us see the HTML the HTML page, which is the web component. So web component basically makes use of the read account balance API, which is exposed using the bridge, and it also creates the iframe where the add page is used. Okay. Now let us see the add page, what it does. So add page basically uses the handle and writes the account balance and updates it to 0, which means that now using the web native bridge handler that is exposed, the add page also can write to the system resources, thereby indirectly changing the attributes of the main page. So there is a same origin policy bypass that can be achieved because of this behavior, because of the bridge that is being exposed here. Clear? Yeah.
Just a question on this.
Yeah.
So that aligns with the basic guideline that attack vector use of functionality.
Sorry, can you please?
That aligns with the basic classification use of functionality.
Are you saying that this has this been abused actually?
Yes, until you are saying. So does it shows the WASC classification of abuse of functionality?
Yes, yes. Actually, this function, this I mean, this attack vector has been actually used in a lot of hybrid mobile application and has been abused in the wild. So I will show you some slide which basically shows articles about it. Okay. That's your question, right? Whether this particular handle has been, like this particular functionality of SOAP bypass has been used in the wild for abusing, right? Yeah. So, so these are the articles, like where like uh, the ad page has gone malicious, and a malicious ad page can actually access the handle, and it can get access to all the native API that is exposed, and which can actually bypass the SOAP. Now let us go to the next attack vector, which is Java based reflection attacks. Okay, so what is Java reflection? So reflection is a feature that is provided by Java, which at runtime allows you to get information about a class, get the methods which are used in the class, and also invoke those methods dynamically, right? So where is this used? I mean, this is usually used in IDEs. For example, when you type object dot and it lists all the methods that the object supports. So internally the editor, right, say Eclipse, right? So they make use of reflection to basically get the method information of the class and list it for you, right? So this feature of Java reflection can be abused, and we'll be explaining we'll be seeing what attack can be performed on that. So before that, let us see how how reflection can be how reflection can be done on a bridge. So this is the handle that I'm exposing in the native layer, and basically I call dot get class dot for name. I get a runtime object. Basically I do get runtime and get the singleton object of runtime class, and finally there is a invoke. I invoke. Uh, 1 minute. Yeah, so there is exit method that is called. It's not. Yeah, so I invoke the exit method of that particular runtime object. So let us see what bad you can cause because of this. So I have this chat page where the attacker has given a lot of links to me. So let me click the first link, which is SD card. So you see that all the SD card information is there on the screen, and it should also be sent to the remote server. So all the SD card information is sent to the server, right? So again, going back to the native code, there is nothing that is being exposed. So if you see the JavaScript handler or the the class is empty actually. So there are no APIs that is exposed. But instead we make use of the reflection property of the Java class to basically get access to the runtime object and finally invoke the method exec, and we try to run commands on that. Okay. So native code is comparatively very less, and it's kind of doing nothing but exposing a Java handle, but there are no methods that is being exposed. However, if you see the native component, the web component, so you have this JS handle, and as I showed you earlier, it makes use of the runtime it gets a singleton object for runtime class, and uses the calls the method exec. Yeah.
So this would only work if the current whatever file that you're executing has access to that method, right? Or if it's a public class or if it's a private class in a different package, then you can't run it.
Yes. So in fact, this time I'm doing LS on MNT SD card, right? So SD card is having a global property where anyone can access the SD card actually, right? Provided you have a permission write storage and read storage, right? So if you have this permission, then you can either write to SD card or read from SD card. Okay. So permission plays a role here, but otherwise, like if the permissions are there for the mobile application, then it can actually make exec and do LS MNT SD card and get the listing of all the SD card, and basically the code next to it, right? XHR send, it basically sends it to the remote server. Does that answer your question?
Yeah, kind of. I'll follow.
Okay. Yeah.
So basically, you are telling that even if it's not exposed, you can access like almost all of the device functionality based on it.
Exactly. Yeah.
So is it available? I mean, the same thing applies to the latest version of Android also, or
No, it is not. It does not apply to latest version of the Android. So these attack vectors they don't work in 4.4 and later actually. So all the
specifically about the reflection?
yes, reflection. Yeah, I'm also specifically referring to reflection actually. This reflection based attacks don't work on 4.4 and later. Correct. This is because Google has changed the browser that is being used. So earlier it was a ASP browser that was being used. Now it is a Chrome based browser that the Google is using since 4.4 onwards. And because of this, reflection based attacks don't work. And for it, this only works for Android version below 4.4, KitKat, Jelly Bean, Ice Cream Sandwich, etc. Those versions. SOP works even now. I can demonstrate it to you. So SOP works even the latest 5 or 5.2. You have Lollipop. You can try it on that. It works that as well. Yeah. That's I would say that that's mainly a architectural flaw actually. So probably Android should have thought about it when they are designing the architecture itself. But this they have addressed it. Okay. So let us see what some more attack vectors again based on the reflection. I hope you understood how the attack works. So let us see how some more attack vectors on reflection. So let me click on the second link SMS, okay, and let's see what happens. So it gives a message, and I should get message. Okay, you see that I'm getting message your pawn, right? Okay, it's going on. Let me close this because I'll be charged. Yeah, so basically it's spawning the message in a loop, right? Now let us see the code behind it. So we'll only be seeing the web part of the code because the native code is the same. It does not expose any methods. You just have a bridge handler which is exposed, but you're not exposing any of the methods. We are using reflection to get access to the APIs which are not exposed actually, right? Uh, the web component for the SMS stuff. This is how it looks like. So I have the JS, the web native bridge handler here, and I get a singleton instance of SMS manager. So get default, I get the singleton instance of SMS manager class, and then I invoke I invoke the method send text message. So send text message is one of the member methods of SMS manager class, and using reflection I invoke that method, and finally I think I do it 3 times. I think it's a looping for 3 times. Like a malicious guy probably can do it for 100 times or 1,000 times, and instead of sending it to myself, self, right? He can actually send to some premium numbers, thereby exploiting, increasing your phone bill, right? Let us see the next attack vector on this reflection. This is an interesting one. This is shell injection. So let me open. I'll open a listener. So I'm listening on port 444. So from the phone, let me click shell. Okay, nothing much happens, but in fact, I get access to the device. Okay, so I get the root. Okay, some path problem. So this is a listing from the phone. So attacker gets the listing from the phone. He can do a lot of things. He can DSP card -AL. He gets the listing of the SD card. He can see all the processes that is going there. Should work. Probably take some time. So basically, I have injected a shell into the device, which basically sends information, which basically takes the commands from the attacker and sends the information back to the attacker actually. So let me see, let me show you the code. Again, I'll be showing you on the web part of it actually. Native component has nothing there. Just exposes the bridge handler. So I have so again I have the handle here, and I make use of the runtime object and get the runtime object. I have the shell here. This is a reverse shell. This is the ARM shell that has been hard coded here. And what I do here is, like I write the shell to this particular path. It creates a file called shell code, writes the file there, and then I give the, this is the code which basically writes the shell to the file, and then I set the necessary permission for the file because it has to execute there, right? And finally I execute the shell itself. Pretty straight. Okay. So we'll go to the next attack vector. Okay, for the next attack vector to work, I need to start @, server. So just give me a minute. So this @, is a project done by graduates actually. So it works like the similar concept. It has the same concept as that of a shell actually. So this attack, what I'll be doing is I'll be the page basically will be creating a APK file in the device. It will be automatically installing that APK. It's a Trojan actually, and then it will be sending the. It will be basically listening to master's command, which means the attacker will be sending the command. Okay, send me the like SMS list, and this particular Trojan which is there in the device, it will be sending that information, and you can do a lot of things actually. Okay. So this is the attacker's console, and I have the device next to it. So before I go further, let me show you that this this is my SD card listing. There is no file called andrew.rat.apk. It will be created now. So no message there. So I'll go to the file here. So by default, this attack should also install this APK file, but unfortunately, the device is not working. But I'll show you the simulator again. It automatically installs there. Let me manually install it now. So this page has created the file called android.apk in the SD card, and the user installs this application. And you can see that information about the phone is basically sent to the Android server that is running the attacker's box. Now I can do a lot of things here. Let me. I can basically send a toast message. Say you're hacked. You're hacked. So you should see that message in the phone. You're hacked, right? And I can do a lot of other things. So before that, let me open a simulator and let me show that it automatically installs the Android APK as well. Simulator. Okay. Why is it? Okay. So let me. I'm doing the same thing. Um, So okay, before this, let me show you that there is no Android APK application here. There is no Android APK or application that's installed here. And let me quickly open this thing and click on Android. And you see here that Android APK is installed. So which means that now I didn't have to go to the SD card and actually click it. So this in the simulator we can see that it has actually created the file called android.apk. When I access the page, it has also installed that application, and when the user clicks on the application, it basically sends the information to the attack. So you can see two entries there, one from the simulator and one from the phone. So let me show you an interesting attack that can be possible here. I mean, there are a lot of things that can be possible, but one of my favorites is that you can actually attacker can now listen to your phone calls, right? So let us do that. Let me click on this. So you can see that all the phone information is being sent to the attacker. Now the attacker audio. So the attacker is listening. Hello, hello. See, it's being replayed by that. It's coming in the attacker's machine actually, right? Okay, you're able to hear this, right? Let me just close it. Yes. Okay, so you can do a lot of things. You can even capture the videos remotely. You can turn on the camera. You can take pictures. You can take videos of the person without even the user getting to know. Now, if you see my phone, nothing is happening there. I mean, the user does not know that whatever he's speaking, like he's being tracked by the attacker. He's being listened by the attacker. It's not at all possible, right? So there are a lot of attack vectors possible. I would really encourage you to go and check what this Android does. A lot of things here. So now let me, I think this is the attack vectors that I had, attacks demos that I had. So let me quickly, let me show the code for this, the web part of it. Okay, so this is the android.html file. This is, as I told you, the native component again the same thing. I'm using reflection. So JS handler, the bridge is being exposed there. No API is being exposed. So using the bridge, I do a reflection here, the same reflection runtime object. I get the runtime object, and this is the APK. So what I have done is I have taken the like Android APK. I have converted into hex, and I have actually hard coded here in the page. And finally, I write this into MNT SD card. So the first this basically removes the Android rat.apk if it's already installed, and then like I read. In fact, I have to do in multiple parts. If I do it in single command, it does not work. So I have broken down that APK files in multiple parts and converted to hex, and I write it using multiple commands here. Okay, and I concatenate that. And finally, I run adb install /mnt card. So sorry, slash adb install mnt card sd card and android.apk. Basically, I install the application there. So this page automatically creates the android.apk file. It installs it actually, and then there's the attacker is able to gain complete access to your device. He can listen to your phone calls. He can do a lot of things. Now let us come to the last part of this presentation, which is the solutions. How do you solve this? Yeah, by the way, the shell injection that I talked about, right? It was not only, it was also demonstrated on devices like Google Glass. Okay, so how do you secure this web native bridge or the web view, right? So there are a lot of things that as a developer or as a security professional, you need to take care to ensure that such kind of attacks are not possible in the application that you're certifying or application that you're developing. So the first thing is the permissions, right? So you have to ensure that only the necessary permission that is required by the application is actually there. If there are any extra permission, then that is an issue. Okay. So for all these attack vectors to happen, I have actually given the permission. For example, and or at basically, I have there are permissions like SMS manager, permissions for the call. All those actually hard coded. However, if those permissions were not there, it wouldn't work actually, right? So you need to only have those permissions which are really required by the application. Next, you should not expose now that's you should not expose any methods which are not needed. For example, if you are using some framework like PhoneGap, right? As I told you, it will give n number of methods for the developers, but the developer has to whitelist the ones that are actually required, right? And eliminate all the other methods. So if you expose more methods which are needed by the application, then that's an issue. So as a security professional, you need to ensure that only the ones that is really needed are actually there. Then we talked about the source bypass, right? Remember the ad page getting the access to the web native bridge and it making call to the system resources using the native API that is exposed. How do you prevent that? So when the application loads, you can actually the native code can actually create a cookie, right, for the domain that it wants to connect to. So native code will be creating the cookie. Okay. Now this cookie can be accessed by the web page because it's in the same domain, right? However, the ad page will not be able to access this cookie. So whenever this, like whenever the HTML page or the JavaScript basically wants to connect over the bridge, want to talk over the bridge, it has to send this token over the bridge. So the token which is stored in the form of a cookie need to be retrieved and it has to pass it on the bridge. And the native code has to validate whether this is a valid token or not. And only if the token is valid, then access to the system resources, else don't. So now since ad page is in a different domain, it does not get the cookie, it cannot actually make a call to the system resources. So this way we can prevent same origin policy bypass. There are different methods to it, but this is one of my favorites. Again, as I told you, this attack vectors are possible below 4.4, like 4.0, 4.1, 4.2, all these are susceptible to these issues. However, in 4.2, Google has introduced a feature called annotation, where you can annotate that at the rate JavaScript interface, and only if you annotate the method in the native code, can that method be exposed to the public. So if you're using a PhoneGap, right? So a framework like PhoneGap, there are n number of methods. You have to actually annotate this particular method, and only then those methods are accessible to the web component, right? Again, now in this examples, whenever there are links, right, I'm opening the link within the web view, right? Now, since it's within the web view, you have the access to the bridge and all these attacks are possible, right? However, a better solution would be that like open the links in a different browser. Like if you open it in an independent browser, then same origin policy and all these attacks are not possible. There's no bridge available there. Okay, so these attacks are not possible. So programmatically, it is possible to like have the links open in a different browser instead of the same web view. Again, you have to use SSL. All the communication should be on SSL, and I believe we'll be having a debate on that after this session. Okay, so as you saw, we were using add JavaScript interface API, but there are other ways of actually establishing a bridge in Android. But those are all tweaks. But Google recommends that you have to use add JavaScript interface, but it's having a lot of security flaws. But there are other ways. So literature basically say that if it is possible, if the developers have the expertise, better to have like these tweaky methods which are having lesser security, which are which don't have any security issues reported. So it's better to have a tweaky approach for this, which makes use of methods like should override URL loading. And as I told you, like reflection does not exist with the 4.4 and higher, as Chrome browser is used. These are some of the references. Very good read. Yes, that's all I have. I hope you have enjoyed the demo and the presentation. Thank you. You have any questions? I can take it. Yeah, sure. Okay. No, it will not work. You have to enable that to install this. That's right.
And one more thing, like if the user comes to know like this app got installed in this mobile and it wants to uninstall it, so is there any way to prevent it, like prevent the uninstallation of this thing?
Prevent the uninstallation. I'm not aware of any. I got what you want to say. Actually, it's like you have this app installed, but you don't want to allow him to uninstall that, right? Directly it is not possible using the web view. Probably you need to have some kind of a process that's injected there, which keeps on installing it and so forth. But it's not possible using the web view kind of attack actually. You need to have separate attack vector which will make use of it, and repeatedly keep installing and checking if it's not there. You repeatedly install it actually. Yeah, but it's not possible using the web view kind of attack. Yeah, because here it requires the user to connect to the server, get the page, malicious page within the application, and then the attack happens.
So hiding is possible, like hiding behind another application.
Yes, yes. Actually, see this. I have named it as Android.apk because this is the project that's done by the grad students actually. However, you can name it anything. You can have Citibank.apk actually. They may not know, and you can even change the logo. You can have the logo in that HTML page, and you can dump it into the. You can do all those sort of things. Yeah. So user may not come to know about it. Any other questions? Yeah, sure.
So this is a lot of content.
Okay.
Are you willing to actually split this into 8-hour session into a Hamla session for everybody?
I can do that. I can do that.
Okay, I will connect after this.
Sure. I can do that. Yeah.
So we put you on the spot when you're speaking, so you can't say no.
No, I can do that. Yeah, but I think 8 hours is a little bit too much. Probably I can add more content. I have more demos actually, which I could not, have it in this 1 hour. Probably I can show all that in the Hamla. Yeah, cool.
Content and how to do it.
Okay, excellent. I can do that.
Thank you very
Yeah,
much.
yeah, no problem.